Welcome to 2,000 pupils across Southend for our primary feeders at Chase High School. I'm Mr. Foster, I'm the head teacher at Chase High, and welcome to our first live science event.
Okay, so welcome to Chase High Science Week 2021. My name is not Anna Wilson, as you may see in the corner of your screen. My name is Mr. Brodigan. I'm head of science. I've been here for 12 years, and today we're going to talk you through what it would be like to live on Mars, what are the challenges we face, what kind of skills you're going to need if you're going to go there one day. And I put together a selection of what I think are really interesting experiments to kind of explain to you some of the facts. Thank you for joining me here today on what I've chosen as being a very special day. National Science Week does not start until tomorrow. However, when I looked at the calendar, I thought today would be a really important day to hold it on, because if you look at today's calendar, what's the date? It's the 4th of March 2021, or if we shorten it down, it's 4321. So let's get ready to blast off into space, and let's answer some of your questions that you've sent in to me, and let's talk about Mars and get you really excited about science for this year's Science Week. So I'm going to go through a couple of questions, and then after every couple of questions, we'll show you some videos and we'll talk about them. So the first question that's come in today is from Amber, who's in year 5. And Amber asked me, can you see Mars through a telescope? And so for Amber, the answer to that question is yes, you can, and it's not can you, it's when can you. The thing that you need to know is that Mars and Earth are not always the same distance apart. So as I'll be showing you later in the presentation, that there are specific times when Mars will come closer to Earth. And we know that this has been happening throughout history. If we look back into ancient Chinese Roman records, they talk about the red planet. Mars is named after the Roman god of war. And so in Roman times, they connected the red colour of the planet with kind of the colour red from the blood of battle, and that's how it came to have its name. Okay, so I hope that answers your question. Tom, who's in year 5, says, are scientists looking for life on Mars, and have they found anything that could lead to life on it? So if you've been paying attention to the media, we have just landed the Perseverance space rover on Mars. This is our fifth rover on Mars. We've had 49 missions, and we have landed in a place called Jezero Crater. So Jezero Crater is a big lake-shaped depression on Mars, and what we're hoping to find is, we know water exists on Mars, and we think that this is where it would have been a lake, so therefore we're going to be looking for the remnants of Martian life, and hopefully we don't think we'll find fossils. We don't find fossils on Earth when from early periods in history, because they didn't have hard things like shells and teeth and claws, but we are looking to find molecules. So I'll be talking to you later in the show about how these molecules could be tested for and find out about them. Okay, so that's what today is all about, life on Mars, and could we live there? Another question here is from Seb, who's in year 3, and Seb says, how does the rover move on the rocky surface of Mars? So let's take a little look. So this is Mars. Okay, so Mars is the red planet. So what you'll see on every slide that we have here, here at Chase High, we're all about character education, and so you see in the bottom left here, we've got leadership, organisation, resilience, initiative, and communication. So these are all the skills that you would need to be a successful astronaut, or an astronaut going to Mars. And so we'll be talking about them today. Okay, so let's have a little look through. So this is Percy. Percy is the short pet name for the Perseverance rover. We've just landed on Mars. And what makes it really interesting, for me anyway, is that 2 of the sensors that are on Percy were built locally. So scientists in Chelmsford have built 2 of the sensors on here that allow us to do some scanning and analysis on Mars. And I think that even though this might have been launched in America, and maybe it's built by NASA, the fact that science came, some of the science came from locally, just shows me how much opportunity there will be for everybody here that's paying attention today to kind of go out into the world and become effective scientists. So a question from Seb, who's in year 3, says, how does the the rover move on the rocky surface of Mars. Okay, so on this, it looks like the wheels here are rubber, but they're not. They're made of titanium. That helps them grip Mars' surface. Mars is a rocky planet. It's the fourth planet from the sun. It's rocky like Earth, but it's a lot smaller. How a good way of explaining the size of Mars is if you think of the Earth, take away all the oceans, and if you joined all the continents together, that land mass is about the same land mass as Mars. Okay. So Blake, who's in year 3, asks me, how was Mars discovered? So for long times, every time that Mars came close to Earth, it could be viewed in the sky. But the first person to actually look at it and study it through a telescope was a guy called Galileo Galilei. And Galileo was in trouble at the time of his studies because he had this idea that the sun was at the center of our solar system, and everybody else told him he was wrong, and that because humans lived on Earth, that the Earth should be in the center. And it was a bit of kind of a religious argument. But Galileo was proved right, and how he did that by using the telescope. And so one of the things he did, he looked at Mars and he wrote about the features of Mars. Okay. Now, let's look at some more people. So what we'll do, we'll look at some images, and then we'll link to some experiments, and we'll kind of do that back and forth, back and forth. Okay, so some famous people here. Now, the person on the left here, I didn't know until one of my science teachers told me about it. This person here, her name is Alyssa Carson, and she is the youngest person to have passed all the training needed to go to Mars. So she attended space camp in America, and she passed all their rigorous tests, and now she will be planning to hopefully go to Mars one day. So what do you need to go to be an astronaut in space? Well, you need a degree. So you'll need to go through primary school, secondary school. You'll need to go to college and then on to university. And you'll need to study science and maths. You'll need 3 years experience, and then you'll have to go undergo a rigorous fitness test. But it's possible. The person that's making a lot of this possible is on the right-hand side. This is Elon Musk. You may have heard of him. How I would describe him is kind of like a real-life Tony Stark from the Avengers, the guy that set up Iron Man. He is big into his technology. Only this morning he was showing he's got a new rocket he plans to launch into Mars. And what he does really well is that he sends rockets up, and then he's able to save most of them and reuse them. Okay, and that seems to me like a really important time to show you some rockets in action. Okay, so let's see a rocket that I've built for you in action. Let's have a look at that right now. Okay, so I'm going to show you another video very quickly, but that was a rocket, and that was kind of like a small version of a rocket, because we don't have the option to make rockets as big as we want. You see, the issue with rockets is the thing called the rocket equation. So we can work out that the idea is basically most of a rocket, when you look at it, is actually fuel. And so the more fuel you add, the heavier the rocket gets. So there's a limit to the size of the rockets that we can send up. So inside the rocket, we burn a fuel, or that's known as a propellant. And the idea is that Isaac Newton was a famous scientist, and he was the first one to really talk about gravity. And he had a number of laws. He had 3 laws. And the third one, he said, every action has an equal but opposite reaction. So that when we set fire to our propellant, it's going to create a force, and it's going to push in the forward direction, but at the same time it's going to push in the backward direction. So every action has an equal but opposite reaction. And so that's what we're seeing there. So I'm going to show you now my next rocket, and I'm effectively driving this rocket into the floor. It's the only safe way to do it, because if I did it in any other way, I would probably put this rocket through the window. So have a look at this. This is pretty nice. Okay, so I'm just going to jump you on to the next one. could see there the flames coming rushing out the top of the whoosh bottle. So that was creating a force in that direction, and because of Newton's third law, there's an equal but opposite reaction in the opposite direction. So that rocket was being forced down into the floor, but the floor was too hard. So if I had to flip that over, I would have gone up through the ceiling, and I'm not allowed to do that. You can imagine. And that was only 1 centimeter cubed, or what you might be more familiar with is 1 milliliter of fuel. So a very, very small amount. So you can imagine if I had huge amounts of fuel, just how much force I could create. Okay, so moving on. Now, what we want is, okay, let me see. Okay, so we want to talk about launching a rocket to Mars. Can you do it any day of the week? Can you do it whenever you fancy? No, the truth is you can only launch to Mars at particular times. There's a thing called the Hohmann transition orbit, or the Hohmann transfer orbit, sorry. And it is a point at which Mars and Earth come very close together. So they occur approximately about every 26 months. So the next time that Mars is going to be particularly close to Earth is next year, next December. Okay, so we just missed one last October. We're going to have one next December. And so you'll be able to see Mars a lot more clearly. And also means if we want to send a mission to Mars, then that would be the right time, because we need to make sure that the 2 planets are as close together to send the rocket from Earth to Mars, because if they're further apart, then the journey will take longer. At present, it takes between 7 and 8 months, which is quite a long time. And that's one of the challenges we'll face if we ever move to Mars. At the moment, we send astronauts up to the International Space Station, and they stay there for 6 months. And while they're up there, because of the reduced gravity, they don't need their muscles as much, they don't need their bones as much, so they tend to become less dense and weaker. So the astronauts on the International Space Station, they have to exercise every day, so they run on treadmills where they're anchored down, and they have machines that provide resistance. But even then, when they come back to Earth, they're incredibly weak. So that will be a challenge that's going to face us if we send people in a spaceship for 8 months to Mars. Then their muscles are going to be reduced in strength. So that's something that we need to think about. Okay, so Jack from year 5 has a question. Says, is it possible to live on Mars? So I think living on Mars is very similar to living on Earth. Is that you need 4 things. You need food, you need shelter, you need water, and we've got food. We've got clothing. Food, shelter, water, clothing. And on Mars, we need one other thing. We need oxygen. Okay, so these are some of the challenges that are going to face us. Now, before we discuss these, I've just told you that we're going to travel to Mars. While we travel to Mars, we're going to be using the orbits of the planets. And what are the planets orbiting? What is this yellow bright point in the middle of our screen? That's the sun. Now, what is the sun? The sun is effectively a massive hydrogen explosion. We can't hear it because there's no air particles in space to transfer the sound, but it is exploding right now, and I'm going to show you a hydrogen explosion. This is a loud one, and this is possibly the most scary one that we have. Enjoy. All day, every day, we're living off and feeling the energy that's given off from this massive hydrogen reaction in our star, which is the sun. So now that we're on the surface of Mars, the next question we have is from Hugo, who's in year 5. And Hugo says, how does a planet lose its atmosphere? So Hugo must have been doing some research and understanding that Mars has got a very different atmosphere than Earth does. So here is the very thin atmosphere of Mars. The atmosphere is the layer of air surrounding the planet. And so Hugo wants to know, is it possible to recreate or force one back if it's lost? And how is it different than what we've done to Earth? as a species. So I've written quite a long response to this one, which I'm going to send out to Hugo. But ultimately, what is important here is gravity is a pull, not downwards, but towards the center of a mass. So if you think of the planet being spherical like a football, gravity is pulling everything towards the center. The size of a planet affects the gravity. So a small planet has less gravity than a large planet. And that may be responsible for some of the atmosphere being lost. So the atmosphere on Mars is a lot less. So it's 1%, as I'm going to show you now in a video, 1% of what's going on here on Earth. And because it's a reduced atmosphere, it means that the temperature conditions are affected, and we will talk about that as we come down through. But the idea is we are going to be able to hopefully change the atmosphere by doing some very, very clever science. So we're looking at using huge solar arrays, massive mirrors in space, to heat up the North Pole and the South Pole of Mars, where there's huge amounts of frozen carbon dioxide. And we want to fill the atmosphere of Mars with carbon dioxide. Now, we don't want to do that on Earth because it's making Earth really warm and it's affecting our weather and melting polar ice caps. But on Mars, where it's a lot colder, this seems to be what we want to do. So we're going to load up the atmosphere with carbon dioxide, and that's going to warm everything up, and then it's going to make it easier for us to live there. So let's talk about the pressure situation on Mars and what that might look like.
One of the big challenges that we might face if we move to Mars is the idea of atmospheric pressure. Right now, the atmosphere is pushing down on my shoulders and it's trying to crush me and push me down. When I wake up in the morning, I'm a little bit taller than I was the night before because the gaps in between the bones in my back have spaced out. Now, if we assume that there is one Earth atmosphere pushing down on my shoulders, the same situation is not true on Mars. Mars has a very thin atmosphere, and so there's approximately less than 1% of the atmosphere of Earth. And so if that's not pushing down on our bodies when we go to Mars, there's going to be issues. The air inside our bodies will be pushing outwards. There won't be the same force pushing inwards. And that's going to cause us to swell up, and potentially we may explode, which we don't want to happen. So I know most people don't believe me when I talk about atmospheric pressure, so I want to show you how powerful the atmosphere really is. So in this can, I have a small amount of water and I'm heating it. So I'm going to turn up the heat and I'm going to boil the water inside the can. And what's going to happen to water as we heat it? The water is going to boil, the water is going to turn to steam, and the steam is going to push all of the air out of the can. And then I'm going to do something very clever. I'm going to flip the can upside down into this trough of cold water. Let's find out what happens. Okay, now the water inside our can is boiling. You can see the steam coming from the top of the can. The can should now, in theory, be full of steam, and that's pushed all the air out. So let's flip it upside down inside a trough of cold water and see what happens. And so, this is our can. So what's happened to our can is there was no air inside the can pushing out. The atmosphere outside the can was pushing in, and the atmosphere has completely crushed the can. When we get to Mars, there's going to be no atmosphere pushing in, but the air inside our bodies will be pushing out. So the opposite will happen to us. We'll swell up like blueberries, and if we're not wearing our Mars suits, then we could explode.
Okay, so the next question comes from Evan, who's in year 5. Evan says, what's the temperature on Mars, and are there 4 seasons on Mars? So let's talk a few things about how Mars is different. So Mars doesn't have days like Earth. Well, they're not 24 hours, if I put it that way. So how a day works is it's the amount of time for a planet to spin around one time. So a planet you've got to imagine maybe like a football with a large kebab stick running through the middle, and axes so it can spin. So Earth takes 24 hours to do a full spin. Mars takes 24 hours and 39 minutes. So a day on Mars is slightly longer. So we don't call them Mars days, we call them sols. So if you're ever doing any research on Mars and you hear about sols, S-O-L, Sol 1, Sol 85, it's a Mars day. Now, the second thing you need to think about is years. A year on Earth is 365 and a quarter days. So every year we count 365 days, and we save up that quarter day, and we save it up for year 1. So that's a quarter. Year 2, that's a half. So a quarter plus a quarter. Year 3, that's 3 quarters. And on year 4, we have an extra day, and that's why we add in a leap year. Well, on Mars, the Mars year is about twice as long as Earth. Okay, just a little under twice as long. And so that reason is because Mars has got a longer orbit to travel around the sun. So that's why years are longer on Mars. Now, like Earth, Mars is tilted. So it's not like this, it's tilted on an axis and it spins this way. And so this means that Mars has seasons like Earth. It's got a North Pole, it's a South Pole, it's got an equator. And so the temperature ranges differ. It's a very cold planet. The hottest that it ever gets up to is typically around about 20 degrees. So if I think about outside today, probably somewhere, quite a mild day today, 9, 10. On a nice warm day, it's about 20 degrees. It's about the room temperature in our rooms. That would be the maximum temperature at the equator, so in the hottest place. So you can imagine somewhere really hot on Earth, like the Sahara Desert, and how hot it would be there. It would only be 20 degrees on Mars. So Mars is quite cold. So that at nighttime, the temperature can easily plummet down into minus 100, minus 110. So you're kind of looking somewhere from kind of about minus 50 down to about minus 100. Now, because the atmosphere on Mars is mainly carbon dioxide, at minus 78, the carbon dioxide, so it's the gas, we breathe out carbon dioxide. Most of the air on Mars is carbon dioxide. There's no oxygen. So this carbon dioxide can actually turn to a solid. So on the poles where it's really cold, they look like ice caps, but they're actually solid carbon dioxide. So that's really interesting. So a question from Finley, who's in year 5, and Finley says, did the active volcanoes on Mars have names? And when was the last eruption reported? So I had to do some research on this one, and I came across a thing called Olympus Mons. Olympus Mons is the largest volcano in our solar system. So I've given you a comparison here of Mount Everest, and Mauna Kea is like an underwater mountain volcano near Hawaii. And then we have Olympus Mons. It shows the difference, and effectively we can see that Olympus Mons is over 2 times as tall as Mount Everest, and almost 3 times as tall. Now, we've had to squash Olympus Mons into this diagram, but actually the width of it, I've showed you on a map here, and this is a map of the country of France, and it shows you how wide Olympus Mons was. So Finley wanted to know when was the last reported eruption? Well, unfortunately, it was long before humans existed. The last eruption was about 50 million years ago, which is around about the time the dinosaurs became extinct. So there are no active volcanoes on Mars at present. But I thought that would kind of be a bit of a letdown. So for Finley and for everybody else, I've prepared you a volcano. And so Mars is the red planet. So it's covered in a red soil, which is made up from iron oxide. So the purpose of this volcano is to make you think about Mars, but also it's just a nice fun bit of science. So here is Olympus Mons in my classroom. Finley. Hope you enjoyed that, and thank you for your question. Okay, the next question is from Jessica, who's in Year 6, and Jessica wants to know, has there ever been water on Mars? Well, yes, we know that there's plenty of water on Mars. We tell from several reasons. We can tell from the geography. We can clearly see where there would have been riverbeds, valleys, previous lakes. We also know that the water on Mars, because Mars is so cold, most of the time it's less than 0 degrees, that the water that's there is in ice, and it's covered in the red iron oxide dust. So we don't envisage a problem melting. We do envisage a problem melting the ice, because it's going to take quite a lot of energy. There is quite a lot of water vapor in the air, so we're going to extract the water vapor from the air to become our drinking water when we're there. Obviously, we're going to need quite a large amount of water there if we plan on growing plants. You see, the big issue at the moment is Mars is a planet where nothing grows. And a further question here from Louise, who's in Year 6, and says, are there trees on Mars? There are no trees, and the reason for that, there are no plant life, because the soil is toxic, and that means poisonous. So the reason that the soil is poisonous is it contains an element called chlorine. Chlorine, you will know from swimming pools. We add chlorine gas, we dissolve it in swimming pools to kill any bacteria in there. And likewise, on Mars, that would kill any bacteria and kill any life in general. Chlorine can be an important ingredient in bleach, so we know that it's kind of, it works against life. So we will struggle to grow things on Mars, and we won't be possible with the soil that's there. So we're going to need to think other clever ways of growing. And so one of the clever ways of growing would be a thing called hydroponics. So we, instead of growing on soil, because soil is not actually necessary, what is necessary are the various chemical, what we call ions. So the various metals that we put into the water, metal ions that can be taken up by the plants. So things like magnesium, phosphorus, potassium. So we do it on Earth here. When it's called hydroponics. We set up a tray, maybe like a gutter of water. We suspend the plants, the roots go down, they take up the nutrients, and the roots grow upwards. I'll send some pictures around so that to your schools so you can have a look at what hydroponics are, but we won't be using the soil. So how do we know what's in the soil? How will we be able to, how do we know what's there? How can we tell? Well, one of the big things is chemical analysis. So we want to look at the chemicals there, and we need to do some very, very clever chemistry. So I'm going to show you 2 ways of finding out what's in a mixture, and this should be the first one. This was the carbon dioxide ice caps that I was telling you about. That's what it looks like on the north and south poles. Okay, have a look at this. Slightly. Okay, so this is an experiment that everybody can do everywhere. So if you want to do this in your school, or if you want to do it at home, the only thing you need is filter paper. And you can get coffee filters in the shop. And I'm sure if you ask me, I'll have some filter paper I can send out to you guys. And so the idea here is that marker pens are made up. So our colors, for example, you can see what's on the screen here in front of me, but maybe if we're talking about the second to last dot, that started off. So if you have a look at how that started off, the second to last dot we'll focus on, because this will give us a good idea. So you can see in the beginning it was green, and then as we progress towards the end, you can see now that it's not green anymore, it's blue and yellow. So the marker pen is a mixture. There was green, there was what looked to us like green ink, but that's all that was made up of was blue ink and yellow ink. And so what happens here is we use the water to dissolve, like you would maybe dissolve some sugar in a cup of tea. So we're dissolving the inks, and then the different colors have a different affinity, a different love for the paper. So if here yellow seems to really love the paper, so it holds on tight and says, okay, I'm not going to move. or I'm going to move very slowly. And blue is kind of like, oh, I don't really care for the paper very much, and the blue moves quicker. So we can see in all examples that the blue is the one that really is not attracted to the paper. And so this is called chromatography, and the this is what we're doing essentially on Mars. We're looking at the chemicals, we're separating them out, and then we're taking measurements and saying, okay, this is this chemical, this is this chemical, this is this chemical, and then we know what's on Mars, and we know what we're up against. Okay, so this is one way of doing an analysis. Okay, and that one you can definitely do in school. Now let me share another one with you that you might be able to. Okay, so the idea that different metal ions burn with different colors is one way that we can tell what's in the soil. Every experiment that you see here today is part of our curriculum here at Chase High. So these are all experiments that you will either be observing or doing yourself in lessons. And this is one that Year 11s do. So they burn different salts to find out what's in them. So I'll give them a salt, I won't tell them. So as part of your understanding right now, you think salt is one type of chemical you might put on your chips. But actually salt is a whole family of different chemicals. So I give them some salts that they don't know what's in them, and they set fires to them, and they can tell from the color of the flames that are produced what the chemical is. Okay, so for example, here on the right hand side, I could turn around to anybody in Year 11 and say, okay, we've got a green flame. What kind of ion is there? And they'll say, oh, green, well, that's copper. Okay, and that's the kind of learning that we've got there. Okay, so everything I show you today is something that we do here. Okay, and that's why I love science. Okay, so now this is likely what the habitation on Mars will look like. So initially, we will live in pods like this. So we will run all our power through solar power. So we know we can get water from the atmosphere. We can live initially in pods, and we're going to get power from solar power. We're not going to be able to use nuclear power. The technology is just not there yet. The problem is when you live in these pods, you're going to be exposed to radiation because of the thin atmosphere and a lack of a magnetic field around the Earth, around Mars. You're going to be exposed to radiation from space. So these tiny invisible bullets that are going to be coming in and affecting us and could make us very sick. So long term, what we're looking into is we won't be living in pods like this after we set up. We'll be moving into caves or into lava tubes, so places on volcanoes where the lava would have erupted from, and this will protect us from the solar radiation. Okay, so you might see these initially, but the idea long term would be to live underground, and living underground has its challenges, but also has its protection as well. Okay, now here we have the solar panels, and one of the big issues that with the solar panels is every day or every couple of days you got to go out and clean them. Mars is incredibly dry, incredibly dusty planet, and if the dust is to cover the solar panels, then they're not going to be able to absorb the energy from the sun and convert it into electricity. So that's what these do. Each one of these panels, and you may have seen these on your calculators, a small little solar cell, they're turning the sun's energy into electricity. And if the dust gets on there, it's going to cause problems. So dust for me is going to be a huge issue. And I'm going to talk to you and I'm going to show you what I mean by dust being a huge issue. So check. this one.
By far and away the biggest problem that we're going to face on Mars is the fact that Mars is such a dry and dusty planet. With lots of dust comes lots of static electricity. The particles are constantly swirling, rubbing off each other, transferring electrons, and that leads to huge dust clouds and electrical storms. Right here we have the famous Van de Graaff generator. We can see 50,000 volts of electricity arcing between the 2 points. And what we're going to do is we're going to have Miss Wilson touch this. So the Skimble is going to first of all turn off the Van de Graaff generator. We're going to discharge it. And then Miss Wilson is going to place her hands onto the Van de Graaff generator. Now, don't worry, I'm completely safe. So, what will be happening on the surface of Mars is the clouds of dust are swirling, they're rubbing off each other, and they're transferring electrons. And these electron buildups lead to huge discharges. So what we're doing here is we're transferring trillions of electrons to Miss Wilson. And they're going to cover her hands, her arms, her face, and her head. And what we want to watch out for is how do these electrons affect Miss Wilson's hair. So if we look really closely, if Miss Wilson gives her hair a big L'Oreal swoosh, we should see what's starting to happen. Electrons are negatively charged. So when you have two like forces, so if you have like the north and north of a magnet or the south and south, if you bring them close to each other, they repel each other. So what's happening here is Miss Wilson's hairs are starting to repel each other. They're starting to push away from each other. And what we should start to see happening, if you look really closely, is that the hairs in Miss Wilson's head are beginning to stand up. Each hair in Miss Wilson's head is trying to escape from every other hair. Now right now, Miss Wilson has become a large bank for electrons. These electrons have been stored up and stored up, and you may have experienced it before. You may have experienced this if you come off a trampoline and you touch somebody, you give them an electric shock. If you walk across particular carpets and you touch somebody, you give them an electric shock. You take off certain types of t-shirts, you get an electric shock. Well, right now, the electrons can't escape. Miss Wilson is standing in a plastic tray, which means the electrons are insulated. And because they have nowhere to go, we can do some really interesting things. These electrons can be used to attract and repel other materials. And this might look like magic, but this is in fact physics. Miss Wilson can even pick up a handful, and if she closes her hand really tight and opens it, you can see how these negatively charged pieces of paper now, because they become coated in electrons, they begin to repel and push away. So this is not wind, this is static electricity. And on Mars, static electricity is going to cause us huge issues. It's the dust of Mars, the dust of the red planet, that iron oxide, that rust dust, that's going to cause us such a problem. This dust will be everywhere. It will be getting on our solar panels. If we were to try and breathe outside, well, we couldn't because there's no oxygen, but if we did, dust could get into our lungs. So it's the dust on Mars that's going to cause us the biggest issues. Okay, Miss Wilson, if you can give your head one big more swoosh. And we can see now, Miss Wilson looks a little something like she should be in the Lion King. Okay, now if we turn off the Van de Graaff generator, of course Miss Wilson's hair goes completely back to normal, like it was before the experiment. Uh-oh. I think maybe Miss Wilson might be permanently like this. No, again, this is only physics. So because Miss Wilson is insulated, she simply needs to find somewhere to put her electrons. So a good place for the electrons to go would be the table. So if Miss Wilson touches the table with her hands, then what will happen? The electrons will leave, they will flow away, and down Miss Wilson's hair goes. Now she might need a hairbrush, but other than that, she should be completely fine.
Okay, hope you enjoyed that one. Now, one of the questions I've had from Kaylee, who's in year 4, Kaylee asked me, is there oxygen on Mars? Well, there is oxygen on Mars, but it's locked up in other ways. It's combined in molecules like carbon dioxide, or it's in the water vapor. So we're going to need, there's not breathable oxygen. So we're going to want to separate it. So luckily we've already engineered this. So probably the most prestigious science university in America, which is called MIT, Massachusetts Institute of Technology, a scientist from there has already engineered a machine called the MOXIE, M-O-X-I-E, and it simply turns carbon dioxide into oxygen that we can breathe. So yeah, we've got that problem solved. And then what we will do is we will fill up oxygen tanks and we'll attach them to our Mars suits. So these are actual Mars suits as they've been developed at the moment. So they offer, because there's an atmosphere, albeit a small one, on Mars, they don't need to be as bulky as space suits. And these wouldn't be suitable for spacewalks, but definitely suitable for Mars walks. And so you could have a choice of each one. I think I would probably go for the one on the right hand side, but that's just me. So another question comes from Jessica, who's in year 4, and Jessica asked me, is there gravity on Mars? Yes, Jessica, there is gravity on Mars, but as we said previously, because Mars is a smaller planet, it therefore has smaller gravity. It's about 38%. So if you think 38% is close to 40%, so if gravity on Earth is a 10, it makes gravity on Mars a 4. So it still pulls you down, but not with the same force. So it would possibly be likely that you could jump higher, depending on how much extra space or Mars suit you're wearing. You could possibly jump over a car, something like that. Okay, so gravity is there, just not as strong. Okay, so again, if people go to Mars, when they return back to Earth, they will suffer from weaker bones and weaker muscles, and initially when they arrive back on Earth, they may not be able to walk or may need support getting around, and they need a lot of physiotherapy to build that back up. Okay, so we've answered questions such as, is there gravity on Mars? Is there oxygen on Mars? Is there water on Mars? We've talked about that. We've talked about the different temperatures and the temperature differences and the fact that you can't grow anything on Mars. We've also looked at, are there active volcanoes on Mars? And there's not. Here's a good question, one from Spencer in year 5, who says, what's at the core of Mars? So we're able to study the core, even though it's right at the center of the planet. We can study the core of Earth and the core of Mars by using sound waves. And so we use sound waves to detect them. And so we know that the core of Mars is made up of iron, but it also contains some sulfur. But we know that the magnetic field around Mars, so Earth is protected because the core of Earth essentially swirls and creates a magnetic effect. So there's a big magnetic field around Earth protecting us from radiation from space. That's not true on Mars. It may have had it initially, but it's lost it. So that's another risk that we face on Mars. So is Mars planet B? Is it the place that we could go to? Well, a lot of people will tell you no, because it's simply nothing grows there. There's no oxygen. It's so cold, there's radiation, etc. But why I love science and why I love Science Week is because we have engineered these problems. Somebody has said to us, you can't do that, and we've said, yes, we can. Okay, we can look at a problem and we can solve it, we can collaborate, okay, through, as I said at the beginning, if you've got leadership and organization, resilience, so you don't give up, okay, initiatives, so you're going to use your own initiative to get something done, and you're going to communicate. And as you've seen when I talked about scientists from Chelmsford working with scientists from America and all around the world, bringing them together, we can solve any problem. There's no problem we can't solve by working together. And so And so that's why Science Week is important to me, and hopefully it's important to you guys as well. So the answer is, can we live on Mars and survive on Mars? Yes, we can. When's that going to happen? Who knows? But as I said, it's going to be every 26 months we can launch a mission. And hopefully sometime before a lot of you guys are grown up, we'll have the first people up there. Okay, so hopefully today's show has made you think and want to ask more questions, and I hope you've learned something. I hope you've enjoyed it, and I hope you've seen what it's like to be a student here at Chase High School. A big thank you to obviously everybody who supported the video in terms of getting things organised, getting the video clips made, and the technicians who put it together, and all the other staff who contributed. Without a strong team behind us, obviously this would not have been a success. So it leads me to finally say thank you all for coming along. I think at a peak we hit about 190 attendees, which is amazing, and considering that some of them have been classrooms, and I could be talking to much bigger numbers. So I've really enjoyed it. I've learned a lot. I've done a lot of research about Mars, and I found out a lot, and hopefully you guys have learned and found out a little bit too. Yeah, keep on doing science, and keep asking the questions, and keep on trying to find out about more about the world. So I hope you found it interesting and engaging. I've been Mr. Brodigan. We've been Chase High School, and we hope to see you all soon. Stay safe, and we'll see you again. Take care. Bye bye.